So we have a very, very brief and simple topic. I want to speak about the statistical average of an operator. To describe what I mean by statistical average of an operator, I first need to introduce the density matrix formalism. So let me define rho, which is 1 over the sum over n, where n is the number of ensemble. We sum all the k from n to n, from k to n, or element of the ensemble of the wave function of the ensemble. Okay, so this is the definition of the density operator. All right. Now let's pick a random operator. Let's call it A. We have this observable, and we want to evaluate the statistical average, which is not a regular quantum mechanics statistic. It's not a regular quantum mechanics expectation value. There is also to consider the ensemble. And how do we do that? We consider first the observable, bracket in this way, but phi, these wave functions, are not alone, they are element of the ensemble. So we need to sum up to all the ensemble from k and divide it by 1 over n, because it's an average. Now we can introduce, it's always possible to introduce in this space a closure relation. So we have P of k element of the ensemble. We inserted, let me do this graphically, like this. We insert a closure relation of some phi n, and we reduce the observable phi of k and finish off like this. Okay, so nothing, because what we just included here, for those of you who don't know, this is just known as a closure relation. Okay, so if the sum of all the projectors are equal to 1, pretty standard stuff. Or completeness sometimes is called, or closure relation. I call it closure relation, but it's some people refer to it as completeness of the Hilbert space. Anyway, what we are going to do now, we take this part. So this part here, it's important to notice that commutes with our part here. So we bring this in front in this way, and we write 1 over n, the sum from k from 0 to n, capital N, which is again the ensemble. I write it up here. N ensemble. Okay. All right. So we have phi n. Just need to copy this part. Phi k. I bring this one on top. So phi k and phi n. Right. Now we notice that if we take this part and we bring it all the way inside here, we obtain, sorry, I forgot that there is an additional summation sign, of course. I will write it more clearly now. So it's sum over n, phi of n, phi of n, a, 1 over the number of the ensemble, the sum over k, from 0 to the number of the ensemble of phi k operator this way, and phi n. Oh, now if we recall the first definition that we gave at the beginning, the definition of the density operator, we can see that we have it here now. This is precisely the definition of the density operator, and we can write then the sum over n phi n a rho. Okay, I avoid to put all these hats. I hate them. They are just confusing. It's clear by the context if I'm referring to an operator or a scalar. So those are all operators anyway. Okay, now we can see that there is the sum over n of phi n a times rho, which is the density operator, phi n, but this is simply the trace of rho a. Okay, so the statistical average of an observable is the trace of the product of the density operator times the observable. And this concludes our short video.